Hey pre-calculus, here we are in section 5.8, the last section of chapter 5. We're going to talk about the law of cosines. Our vocabulary today, or our notes, would be law of cosines and Hero's formula. Law of cosines is a way of gives us the power to solve triangles given some information about them. Notice that the sides of the triangle are related to one another with one angle, with each angle. So we don't have to really, each of these formulas are really the same formula written for a different angle. So what this is showing us is just, hey, if I have side A and angle A, I can use this to relate the relationship between it. Or if I'm looking for side B and I've got side B, I can do this, I can do these things. So I know that didn't make sense, but it'll make sense in a second. I promise, I promise, I promise. So basically you can write down one of these, but it'll apply to all. What I want you to notice, I like the first one, because I see a squared equals b squared plus c squared. Actually, that's not the one I like. I like the last one because I see c squared is equal to a squared plus b squared, which looks just like the Pythagorean theorem because this develops out of that. And so I like to hold on to this. Notice that c is here, a is here, b is here, and then the additional part is that I'm going to subtract 2 times ab times the cosine of this angle C. Why am I pointing this out? What I want you to see is the relationship, because it won't necessarily be angle C or side C that we're looking for. So what we want is the side that we have, or that we're looking for the angle for. Notice that they have to be on opposite sides. That's the same with the A and the B. So if we have a side and we're looking for the angle opposite that, we need to have the cosine of that angle is what we're looking for, and then all of the rest of the stuff, the other two sides, are going to play a part inside the formula. I know that sounds crazy, but it'll make sense when we do some examples. Let's look at Hero's formula. What Hero's formula gives us the opportunity to do is to find the area of a triangle given the sides. Pretty nifty. So what we have to do is find the half perimeter. So if we have a triangle, A, B, C being the sides, if we find the half perimeter and then we multiply that by the difference of the side of each side with the half perimeter, so the half perimeter times the difference of those of the side and the half perimeter, then we take the square root of that, then we get the area of a triangle. So we're going to demonstrate that knowledge and use that in our examples today. So let's go ahead and get started with our examples. Looking at example 1, we're going to refer to the application, which I won't read right now. Really, it breaks down into the situation where we're given some information about a tee, a ball, the cup, and some lengths and some angles here. And what we need to do is find x, okay? And so if that's the case, what we want to do is see how much information we have in order to find the missing information. So I need to find a length. I've got 2 sides and an angle. Do you remember the formula from before? Feel free to go back and review it. But c squared equals a squared plus b squared times minus 2 times ab times the cosine of c. I remember it by thinking of the Pythagorean theorem. Then I have to memorize this little bit here, which is take away 2 times the 2 sides that are kind of not involved in what I'm looking for, and then multiply that by the cosine of the angle that I'm solving the side for. I know it sounds crazy. Memorize it. Try it. Okay, so how does this work out in our situation? The fact that we're trying to find this angle, I'm going to put the x squared here because we have the angle, the fact that we're trying to find this side and we've got the angle across from it is why I'm going to situate x squared here and the cosine of 4 degrees over here. And now I'm going to fill out the rest with the other given sides. So that's going to be equal to 177 squared plus 160 squared minus the product of those 2 times the product of those two numbers, 177 and 160. All of that, make it a 60, all of that times cosine of 4. So much information here. You know you want to make this calculator ready. So there we go. It's calculator ready. I'm going to go over Desmos and figure out what our x, and we get 20.7 yards, approximately 20.7 yards. Okay, so you can see this section is going to be a lot of calculator use and a lot of, making a calculator ready. All right, let's look at our next example. Okay, again, here we are solving for a triangle, but this time we are, actually, it's really the same thing. We're solving for a side. They've labeled it A, which is totally fine. I still think about it, I mean, so we can look at it the other way. So we can think about it as A squared is equal to the other two sides squared minus 2 times those two sides times the cosine of A. You see how it's kind of easy to memorize if you start off by thinking about the Pythagorean theorem. I still like to think about it all as C, but I wanted to orient us correctly. So we're looking for A squared. That's equal to 5 squared plus 9 squared minus 2 times 5 times 9, which is 45. So I guess that's 90, but I'll just put the 45 here since I already write the 2, times the cosine of 120 degrees. And basically it's calculator ready. All I need to do is put a square root over everything. I'm going to run over to Desmos like I do most of the time, and I'm going to calculate my value, and I'll be back with the answer. So I get approximately 12.3 as my answer. Now here's what I want you guys to realize, that we have to solve this triangle. That means we've got to find some other information about it. So let me set up my chart, and I'm going to put in my chart everything that I know. Angle A is 120 degrees, 123, 9, 5. Okay, so that's great. We've got all of this information. So now I've used the law of cosines, but honestly, kind of want to just use the law of sines now, right? Because the law of sines is a little bit easier. I could, I guess, use side B to figure out angle B, then use side C to figure out angle C, but maybe the law of sines might be faster. So if I've got the sine of 120 degrees is over 12.3 is equal to, is actually equal to the sine of angle B over 9, that's going to help me out. And then I can do the same thing. It's equal to the sine of angle C over 5. So what I'll do is I'm going to actually calculate this for each of these. So watch this. So we get these two relationships here. If we just calculate a little bit, sine of B is going to be equal to this, and sine of C will equal this 5 times the sine of 120 over 12.3. So in order to find the measure of angle B and the measure of angle C, we're going to have to do the arc sine of this and the arc sine of this. So when we get our calculator, we take the arc sine of each of those. We get 39.3 degrees for B and 20.7 for C. So that's what solving the triangle looks like. And now we have some extra ammo, which is so here in this second part of this second example, we're going to use the new ammo we have, which is the law of cosines, as we deal with a situation where we're given the sides of a triangle and not much more, right? And so we need to solve the triangle. And so given the sides of the triangle, if I call this side angle A, let's say this is angle B and this is angle C, then side C is here, angle which is 18, side B is here, which is 40, and side A is here, which is 24. Now, the suggestion that makes a lot of sense is that when we are looking for these angles, right, if we're given all the sides, we should find the largest angle first. And the reason why we find the largest angle, or if there's an obtuse angle, we want to find that, is because if we want to later use the law of sines, we bring about some ambiguity. Because you remember, if we're dealing with the unit circle and we think about the different values of sine that we could have, we know that we have identical values of sine in the first quadrant and in the second quadrant, right? So if I had, let's say, angle 30 here, some angle of 30 degrees, it would be the same sine value as this angle over here, which would be what, 150 degree angle. So what we know that there's a little bit of ambiguity when we bring in the law of sines when we're dealing with an obtuse angle, not with the acute angle that stays within the quadrant 1. So let us use our law of cosines to find this larger angle. So how would I do that? Well, remember the formula is kind of like the Pythagorean theorem. Since I'm talking about angle B and I'm looking for angle B, I'm going to start off with side B. So B squared is equal to A squared plus C squared, where I subtract 2 times AC times the cosine of B. When I have situations like this, I like to solve. And so I'm going to solve before we even plug in any values. So if I solve for cosine of B, I'll put it over here. If I solve for that cosine of b, I'm going to be subtracting a squared and c squared from this side. I hope I haven't confused you by switching sides. Hopefully it's not too bad, guys. And then I'm going to divide by negative 2ac. So all I did is alter this equation by isolating cosine b, moving everything over, dividing by 2ac. And now what I'm going to do is take the inverse cosine. So I'm going to find b. So the inverse cosine, or the arc cosine of all of this stuff, b squared minus a squared, minus c squared over minus 2ac, is going to give me my answer. So now I'm just literally plugging this information in. So b squared is 40 squared minus 18 squared. No, I think, well, it doesn't matter, but minus 24 squared to keep up with what we started, minus 18 squared over a negative 2 times 24 times 18. And you can check me and make sure that that made sense. And I'm going to take the inverse cosine with a little bit of a calculator usage. So I'll go do that and come back with our answer. So now that we've got that, 144.1 degree for our measure of angle B approximately. And what we're going to do now that we've gotten this obtuse angle out of the way is now we can use law of sines, which is a lot easier. So if I want to find the sine of angle B, or sine of angle A, let's say, I can recognize that the law of sines will give me this relationship here that I'm writing down. It's going to be the sine of B, which we already know is going to be the sine of 144.1, all of that over 40. And with a little bit of work, we can see that the measurement of angle A, by multiplying these two and then dividing by 40, the measurement of angle A is approximately 20.6 degrees. And so if that's the case, if that's the measure of angle A, and we have the measure of angle B, then of course we can use that information to find the measure of angle C. So by recognizing the relationship between these guys, we're going to subtract 144.1 and 20.6 from 180, and we get 15.3 degrees is the measure of angle C. All right, so you see how we can use a lot of our old math, law of sines, law of cosines, in conjunction with just addition and subtraction to solve the triangle. Let's look at another example. This next example is asking us to find the area of a triangle given the fact that we have the length of all the sides. And so the area given Hero's formula is the square root of s times s minus 4 times s minus 7 times s minus 9. And this s value was the semi-perimeter. So I'm going to find the perimeter and divide it by 2 in order to find s. The perimeter is going to be 11 plus 9. It's going to be 20 divided by 2, which is 10. And then so the area for us will be 10 times 6 times 3 times 1, the square root of all of that. So that's going to be 60, and then 60 times 3 is 180. And so the area is going to be the square root of 108, which is approximately 13.4 units. And that's going to be the end of our examples for today. Hopefully that made sense. We were utilizing that formula, Hero's formula above, and the text did it a little bit different, which is totally fine. They used an old formula for area and then used another example to display Hero's formula. I feel like you guys could take it if we just did that there. And so with that in mind, I'm going to let you guys go. Please take care. Let me know if you have any questions, and I look forward to talking to you soon. Bye-bye.